Okay, so today we are going to be looking at sketching the functions from the graph of a gradient function. So this graph over here is my gradient function. So this is the gradient. We have been doing the gradient function from the original equation. Now we're going backwards. What would the original equation look like? Well, I hope you're sort of thinking, well, I can tell that the equation of this graph is y equals 2x. So that's just something you don't have to know. They didn't have to show the numbers in there. What I'd like you to think is what would have got us to y equals 2x? If what would I have had to begin with? And so if what would have derived to y equals 2x? So we know it was a quadratic. Hopefully you know it was a quadratic. So I would have had some, if dy dx was that, then y must have been x squared. But I don't know if there was a c or some value could have been there. That's not a 6, that's just a c. Just so you know, I'll just put a c there. Some value could have been added to it, and I don't know what that value was from this gradient function. So the best I can do is, it's just my general x squared graph. So I'm just going to start here, and remember we go 1 across, 1 up, 1 across, 2 up, 1 across, 1 up, 1 across, 2 up, and kind of sketch. Oh, that's a very bad, it's a very bad little graph there, but you kind of know what I mean. Sorry, just it's a we're not going to penalize you too much, so we can see there. So I know that that is what it looks like, but to be honest, it could have been down there. Oh, that didn't work. This means just copy and paste it. Control copy, Control V. There you go. It could have been down here. Oh, I've done it twice now. No, I haven't. There you go. And if I go Control copy, Control V, it could have been there. That wasn't what I meant at all. But this isn't this isn't going as a plan. Control C, Control V. Put that back up there. And it could have been anywhere. So I'll just draw it in again. That would be easier. Or it could have been down here. And exactly the same gradient. So basically what we have from our linear equation is some family of quadratic equations that would move up or down depending on what C was. So hopefully you're kind of thinking, oh, okay, yep, that's easily done. What we'd need to know exactly what C was a point on that graph, on the original equation, or a bit more information about my derivative. So hopefully that kind of makes sense. I might actually do this whole thing again, because my whole, no, it's late. I'm going to leave it at that. You can ask me questions. We are working on page 90. So you are going to draw some family of original functions. Remember, we're looking at the gradient function and we are finding what might the original function have looked like. So yeah, see you next time.